In this video, we're going to look at 7 and 8, which refer to domain and or range. On 7a, we have an equation. You can look at this algebraically or graphically on a graphing calculator. If you look at it algebraically, the question is, for domain, what values of x are okay to use? Any value of x will be okay. Any value of x will give you a defined answer. So all real numbers. If you can plug in any number for x here, you should think about whether there are any outputs that would not work. You could plug in any number for f of x and be able to solve for x. So the range is also all real numbers. If you'd rather look at it graphically instead of algebraically, look at the graph of 2x plus 3. You should know that it's a line. Otherwise, you can just type it in to see what it looks like. And you can see that the graph goes on in both directions, y and x, forever. So all real numbers. The second one is a graph. So graphically, we can see in the x direction that the graph starts at x equals -2. We don't want to include x because there's a hole. X is greater than -2, but stops at 3. So x must be less than or equal to 3. Less than or equal to because it's a closed dot. Range is in the y direction. We can see that the graph starts at -2, closed, so less than or equal to x, but x, oops, that's a common mistake, it's actually y, but then the maximum y value is 1, less than 1, because we don't want to actually include the 1. Part C, again, we have an equation, x squared plus 4. Let's look at that graphically. You should be able to tell that it is a parabola. So domain, what values of x are on the graph? This graph is a parabola, so it goes forever to the right and forever to the left. So that's all real numbers. Range, you can see that this graph stops here at 4. There's nothing below that. So y is all values that are greater than or equal to +4. And lastly here on number 7D, another graph. Domain, we can see the maximum x value is at 2. So x is less than or equal to 2. For the y, if we start looking at the y-axis, this goes forever. So in the negative direction, all values of y are covered. But in the positive direction, the graph stops right here at 2. So y is less than or equal to 2. Number 8 is given this inequality, which describes the values of x for which this is true. When is this greater than 0? So you can look at each one and see which one works. All x greater than 2. So 3 or 4 or 5, square root of any number that's positive would be a positive number. So I'm going to circle that. Let's check the others. All x greater than or equal to 2. Well, the only difference here is the equal to. So if x was equal to 2, square root of 0 is not greater than 0. All values of x, well, if you can come up with even one number, so for example, -1, square root of -3 is actually an imaginary number, which is not greater than 0. And we were able to show that this works, so we know that it's not D.